Hello, dear students. So today we will solve some problems. These problems are important with respect to your board examination. So problem number one is this is from optics, and this problem has been asked in your previous year boards. So the problem is like this: the objective of a telescope consists of two lenses kept in contact. One lens has an optical power of 2.0 diopter, whereas the other lens has an optical power of minus 1.5 diopter. And in this problem, you have to calculate focal length of the objective. So, students, we will proceed for the solution. This problem is very simple. Students, here, power of first lens, that is P1, it is given, and it is 2.0 diopter, and power of second lens, it is also given P2, and it is minus 1.5 diop- diopter. This diopter, it is the unit of power. Total power is given by P total. I am representing total power by P total, and it is equal to P1 plus P2. We will simply add these two powers, and it will become 2.0 minus 1.5, and total power we will get it will be 0.5 diopter. And students, we have to calculate focal length, and we know one relationship between focal length and power of a lens. Your focal length is reciprocal of power, F is equal to 1 upon P. And here in this problem, we have to calculate focal length of the objective. I am representing by FO. It will be equal to 1 upon 0.5. And students, uh, I have told many times, if you have number in points, you can just convert it into fraction and your calculation will become simple. So here it will be 10 upon 5 and it will be 2 meter. So we have got our focal length of the objective, and it is 2.0 meter. So this was the solution of this problem. Now we will solve another problem. Let me upload another problem. Now, students, there is another problem. This problem is from magnetism, and this problem is from 2023. Now, first we will see the problem. The problem is like this: a long straight wire AB, you can just see, carries a current of 5 ampere. It is given in the figure. There is a long wire AB and it is carrying a current of 5 ampere. P is a proton traveling with a velocity of 2 into 10 to the power 6 meter per second. You can just see here, P is a proton and it is traveling with a velocity of 2 into 10 to the power 6 meter per second parallel to the wire. Now just see, this proton is traveling parallel to the wire 0.2 meter from it. This proton is at a distance of 0.2 meter from the wire AB, and it is in direction opposite to the current. Now you can just see, current is flowing from A to B in upward direction and proton is moving downward. So the direction of motion of the proton and current, they both are opposite to each other. Now students, calculate the force which magnetic field of the current carrying conductor AB exert on the proton. So students, here we have to calculate the force which magnetic field of the current carrying conductor AB that will exert on the proton. So we'll proceed for the solution. Students, as we all know, if a charge Q, it is moving with velocity V in a magnetic field B, then the magnetic force exerted on the charge Q is given by Q vector V cross vector B. And students, this is in vector form, and if you will write it in magnitude form, it will become QVB sine theta. Here students, theta, it is the angle between the velocity vector of charged particle and magnetic field. So here students, we have to first calculate the magnetic field. We know the magnitude of charge, we know velocity, but we don't know the magnetic field. So first we have to calculate the magnetic field. So students, we'll proceed for the next step. For a long straight wire, for a long straight wire, for a long straight wire, the magnetic field at a distance r is given by mu naught I upon 2 pi r, where the value of mu naught is 4 pi into 10 to the power minus 7. We have current given 5 ampere and we know the distance r also. So we will substitute all these values in the expression of magnetic field. So here magnetic field will become 4 pi into 10 to the power minus 7 into 5 upon 2 pi, the value of distance r, it is given and it is 0.2 meter. And students, if you will simplify this, it will become 2 pi 4 pi by 2, and here it will become 2 into 10 into 5 upon 2 into 10 to the power minus 7. And here 2 will be cancelled out by 2. So here we are left with, that is B is equal to 5 into 10 to the power minus 6, and the unit of magnetic field is Tesla. So we have got our magnetic field, that is B is equal to 5 into 10 power minus 6 Tesla. Now students, now we have got the magnetic field and our expression of magnetic force, it is QBV sine theta. Now students, we have to estimate theta here. What is the value of theta? So students, here you will see, here current is flowing in the upward direction. Now students, if you will use right hand thumb rule, current is in upward direction, and you know, if current is flowing in a wire in upward direction, so using right hand thumb rule, thumb, if you will put your thumb in the direction of uh, current, and if you will curl your fingers around the wire, then fingers curl, it will give the direction of magnetic field. It will give the direction of magnetic field circles the wire. And students, if you will see at a point P to the right of the wire, magnetic field is here. Magnetic field is into the page, that is inward. And here direction of proton velocity, it is in downward direction. So here students, magnetic field is into the page and proton velocity is downward. So here angle theta, it will be 90 degree. And students, now students, you think of 3D axis, 3D axis, downward, downward direction, velocity along negative y-axis, into page, that is magnetic field along negative z-axis. So here y is, as we all know, y is perpendicular to z, which implies 90 degree. So this was the usual way to see it using 3D axis. Now students, now here I am calculating the magnitude of magnetic force. The formula is F is equal to Q VB sine theta. Here magnitude of charge is 1.6 into 10 to the power minus 19. Velocity is 2 into 10 to the power 6 meter per second into magnitude of magnetic field. It is 5 into 10 to the power minus 6 Tesla, and the angle theta is 90 degrees. So it will be sine 90. Students, the value of sine 90 degree, it is 1. And here, if you will calculate it, here 1.6 into 2 into 5, 10 into 10. Now we will simplify the powers after it. It will become 10 to the power minus 25 and minus 25 plus 6, 10 to the power minus 19. And here, students, It will become 1.6 into 10 to the power minus 18 Newton. So this we have got the magnitude of force, and it is coming out to be 1.6 into 10 power minus 19 minus 18 Newton. This is magnetic force. Now, students, we will see the direction of this force. Direction of force. Using right hand thumb rule, right hand thumb rule, students, vector F, it is equal to Q, vector V cross vector B, and here velocity is in downward direction. Velocity downward. Field into the page, into the page, then force on the proton, force on proton, it will be to the right, that is away from the wire. So you can just use right hand thumb rule for this, and this rule is very simple. You can just find it in your book and you can just apply it. If you want, I can just make separate video for this. Here, our magnitude of magnetic force, it is 1.6 into 10 power minus 18 Newton. It is directed away from the wire. It is directed away from the wire. So this was the solution of this problem. Now we will see last problem of this lecture. So let me upload the problem. Now students, last problem of this lecture. Actually, this problem is from current electricity. Just have to apply Kirchhoff's law to calculate the current I1 and I2. There are two batteries having EMF 25 volt and 26 volt. You can just see E1 25 volt and E2 26 volt. They have an internal resistance also of 1 ohm and 5 ohm. You can just see in this figure. And you have to apply Kirchhoff's laws of electrical networks to calculate the currents I1 and I2. So students, we'll proceed for the solution. एक लास्ट क्लासेस में हमने एक प्रॉब्लम ऐसे सॉल्व भी किए हैं, एंड दिस इज, और एक प्रॉब्लम जो है मेरे यूट्यूब चैनल पे एक बेस्ड ऑन किरचॉफ्स लॉ, वो भी मैंने अपलोड किया था, सॉल्व किया था वो प्रॉब्लम। आई थिंक वो प्रॉब्लम 2025 में पूछा गया था, इफ आई एम नॉट रॉन्ग। तो जस्ट वो प्रॉब्लम मैंने डिटेल में सॉल्व किया है, तो जस्ट आप उस प्रॉब्लम को यू कैन वॉच दैट प्रॉब्लम। दैट इज अ वेरी गुड प्रॉब्लम, और ऐसे प्रॉब्लम्स आपके एग्जाम्स में आ सकते हैं, दैट एंड frequently these type problems have been asked in your exams. So students, we'll proceed for the solution of this problem. Here, first we will apply KVL, that is Kirchhoff's voltage law. In loop H J B A F E G H. I am repeating once more. First, we will take loop H J B A F E G H. So here we'll proceed for the next step. In loop H J B A F E G H. Now students, एक साइन कन्वेंशन मैं यूज करता हूं. वो साइन कन्वेंशन कुछ इस तरह है. इफ आई एम मूविंग इन द डायरेक्शन ऑफ करंट, देन उस केस में आई ऑलवेज टेक माई पोटेंशियल ड्रॉप एज नेगेटिव. आप स्टूडेंट्स ऐसा भी कर सकते हो. आप अगर करंट की डायरेक्शन मूव कर रहे हो तो अपोजिट साइन कन्वेंशन भी यूज कर सकते हो. मींस उस केस में आप पोटेंशियल ड्रॉप पॉजिटिव भी ले सकते हो, रिजल्ट सेम आएगा. इट इज जस्ट द साइन कन्वेंशन. बट मैं मोस्टली, if I am moving in the direction of current, in that case I always take my potential drop as negative. So this sign convention I always use. So students, we'll proceed for the next step. Here I have taken loop H J B A F E G H. So here I am moving along the direction of I1. You can just see H J B A. Now just see. अब यहां पे क्या आ गया? I2 आ गया. एंड यहां ईएमएफ है E2. तो जस्ट सी प्लस माइनस. फिनिश कहां हो रहा है? ईएमएफ माइनस पे. तो हियर आई विल राइट -26. अब यहां पे इंटरनल रेसिस्टेंस है 5 ओम का. एंड हियर आई एम मूविंग अपोजिट टू द डायरेक्शन ऑफ I2. तो हियर यहां पे मैं पोटेंशियल ड्रॉप क्या लूंगा? अब यहां पॉजिटिव आ जाएगा. बिकॉज क्या हो रहा है? यहां पे मैं करंट के अपोजिट डायरेक्शन में मूव कर रहा हूं. तो यहां पे पोटेंशियल ड्रॉप पॉजिटिव होगा. तो यहां पे क्या हो जाएगा? 5I2. ना अब यहां पे रेसिस्टेंस 3 ओम का लगा है. पोटेंशियल ड्रॉप B इंटू आई. तो यहां पे क्या हो जाएगा? 3I2 +3I2. तो हियर इट विल बी +3I2. नाउ नेक्स्ट FEG. नाउ जस्ट सी 4 ओम. अब यहां पे करंट जो है I1 है और मैं I1 के डायरेक्शन में मूव कर रहा हूं. तो यहां पोटेंशियल ड्रॉप क्या हो जाएगा? माइनस हो जाएगा. तो हियर इट विल बी -4I1. -4I1. नाउ नेक्स्ट internal resistance 1 ohm, current I1. And here again I am moving in the direction of current. So here it will be -1 into I1. That will be I1 minus I1. And here students, EMF finish कहाँ हो रहा है? माइनस प्लस पे. तो +25. +25. Now students, here we will simplify this. It will become 8I2 minus 5I1, which is equal to 1. -5 I1 plus 8 I2, it is equal to 1. Equation number 1. Now students, we will take next loop. In loop A, B, C, D, E, F, A. I am repeating again once more. A, B, C, D, E, F, A. So here, if you will apply KVL here, then here you will get I1 plus 5 I2, it is equal to 13. Now students, we have to solve these two equations. Now just see how to solve it. सेकेंड इक्वेशन को मैं क्या करूंगा, 5 से मल्टीप्लाई करूंगा. तो अगर मैं 5 से मल्टीप्लाई करता हूं तो क्या हो जाएगा, जैसे पहले फर्स्ट वाला इक्वेशन राइट करता हूं, -5 I1 प्लस 8 I2, इट इज इक्वल टू 1, एंड इट इज 5 I1 प्लस 25 I2, एंड इट इज इक्वल टू 65. नाउ स्टूडेंट्स, अब हमें क्या करना है, I1 को यहां पे क्या करेंगे, कैंसिल कर देंगे, प्लस कर देंगे इन बोथ इक्वेशंस को, तो I1 कैंसिल हो जाएगा. तो बचेगा क्या यहाँ पे, 33 I2, एंड विच इज इक्वल टू 66. तो हियर I2 विल बी इक्वल टू 2 एम्पियर. I2 विल बी इक्वल टू 2. तो ये I2 हमारा कितना आ गया, 2 एम्पियर आ गया. अब सिमिलरली आप I1 को कैलकुलेट कर सकते हो. अब यहाँ I2 की वैल्यू लिख दो, रख दो यहाँ पे. यहाँ क्या हो जाएगा, 10 एम्पियर. तो I1 कितना आ जाएगा फिर, 13 माइनस 10, 3 एम्पियर. तो I1 कितना आ गया, 3 एम्पियर आ गया. So we have got this I2 as 2 ampere, I1 as 3 ampere. So this was the solution of this problem. So I think अगर आपको प्रॉब्लम सीरीज अच्छी लगी तो you can like, share and subscribe my YouTube channel. That's all. Thank you.